Hello everyone. In this presentation, we'll be learning about kinetics of enzyme catalyzed reaction, in which we'll be covering Michaelis-Menten's equation. Michaelis-Menten's equation is based on few assumptions. What are those assumptions? Then we'll be studying about steady state hypothesis and Lineweaver-Burk plot. In 1913, Michaelis and Menten studied a reaction in which sucrose, which is a disaccharide, is being converted to glucose and fructose by enzyme invertase. So they studied this reaction and described a relationship between the reaction velocity and substrate concentration. So Michaelis Menten proposed the following scheme of reaction where your enzyme is reacting with your substrate to form your enzyme substrate complex, and this enzyme substrate complex is later being broken to enzyme and product. Now K1 is the rate constant for the formation of enzyme substrate complex. K minus K1 is the rate constant for the dissociation of enzyme substrate complex to enzyme and substrate. K2 is the rate constant for the conversion of your enzyme substrate complex to enzyme and product. Okay. And you can express Km in this form. This equation expresses your Km. So, according to Michaelis Menten's approach, shows they studied reaction rate at varying substrate concentration. So, at lower substrate concentration, the reaction rate increases linearly. That is, the velocity of the reaction increases linearly. After some point, your velocity reaches a maximum value. That is, the rate of reaction reaches a maximum value. After that, if you increase the substrate concentration to, your rate of the reaction doesn't increase. Okay, and the velocity at which the maximum rate is increased, that is called as Vmax. And what is Km? Km is a substrate concentration at which your velocity is Vmax by 2. And this graph is an hyperbolic plot. So here we are studying rate of reaction versus at different substrate concentration. So at lower substrate concentration, the enzyme catalyzed reaction shows a first order kinetics. At higher substrate concentration, the enzyme catalyzed reaction obeys a zero order kinetics. Okay, or you can say that at lower substrate concentration, your rate of reaction depends on your substrate concentration. At higher substrate concentration, your rate of reaction doesn't depend on your substrate concentration. The rate or the velocity of the reaction reaches a value Vmax. After that, if you increase the substrate concentration to, your rate of reaction is not increasing. Now, why is this happening? Because we are studying reaction rate at varying substrate concentration when your concentration of your enzyme is kept constant. So at higher substrate concentration, what is happening is that your enzyme is completely saturated. All the active site of your enzyme is completely saturated with your substrate. Now no more active site is left. Now if you increase more and more substrate concentration, the rate of reaction will not increase. So Michaelis Menten put forward a mathematical equation to establish a mathematical relationship among the quantities, that is substitution of enzyme, concentration of substrate, Vmax and Km. Okay, so he put forward a mathematical equation to establish a mathematical relationship among these quantities. So this was your Michaelis Menten's equation, that is V0 is equal to Vmax into substrate concentration divided by Km plus substrate concentration. Now this is nothing but your Michaelis Menten's equation, where V0 is nothing but your initial velocity, S is nothing your substrate concentration, Vmax is your maximum velocity, Km is the substrate concentration at half Vmax. So when your substrate concentration is less than Km, the velocity is directly proportional to substrate concentration. When your substrate concentration is greater than Km, the velocity is approaching to Vmax. When your substrate concentration is equal to Km, the velocity is equal to Vmax by 2. Now what is Km? Km is the substrate concentration at which your reaction velocity is Vmax by 2. So when your reaction velocity is Vmax by 2, at that time what is the substrate concentration? That is your Km. Okay. Now Km can also be expressed by the ratio of all your rate constants. Okay. That minus K1 is the rate constant, that is a rate constant for the dissociation of enzyme substrate complex to enzyme and substrate. K2 is the rate constant for the for the dissociation of enzyme substrate complex to enzyme and product. K1 is the rate constant for the formation of enzyme substrate complex from enzyme and substrate. Now Km is expressed in moles of substrate per liter. Now what is the importance of Km? The lower the value of Km, describes the greater affinity for enzyme and substrate. So if your value is low, that means enzyme and substrate are having greater affinity for each other. If your value of Km is high, that means the enzyme and substrate are having low affinity for each other. Michael Menten's equation is based on few assumptions. Okay, now these are the three basic assumptions. First is that concentration of your substrate is greater than of your enzyme. That is, your concentration of substrate is much greater than your concentration of your enzyme. Second assumption is that EC is equal, the formation of EC is equal to the breakdown of EC, that is enzyme substrate complex. Its formation is equal to its breakdown, or you can say that the concentration of enzyme substrate complex remains constant throughout the reaction. And the third assumption is the little accumulation of product, that, or you can say the formation of enzyme substrate complex from EP is negligible. So that the enzyme substrate complex is not being formed from enzyme and product. Okay. So these are the three basic assumption on which your Michael Menten's model is based. What is steady state hypothesis? Steady state hypothesis state that the concentration of enzyme substrate complex remain constant through much of the reaction. That is, the formation of enzyme substrate complex is equal to the breakdown of enzyme and substrate. Okay. Now you can see a graph versus concentration versus time. You can see how is the concentration of your product increasing with time. How is your concentration of your substrate decreasing with time? How is your concentration of your enzyme substrate complex increasing with time? Okay, so you can see that the concentration of your enzyme substrate complex remains a bit constant throughout the reaction. Okay, before steady states, your enzyme substrate complex increases linearly, but as soon as the pre-steady state is finished, a steady state is established, that is, your concentration of your enzyme substrate complex remains constant. Okay. Now what is ET? ET is nothing but your total enzyme concentration, which is equal to, ET is equal to ES plus E, that is concentration of your enzyme substrate complex plus E. Okay. Now let's understand what is Lineweaver-Burk plot or a double reciprocal plot. From the earlier side, when we saw that when you are drawing a graph versus reaction velocity versus substrate concentration, you get an hyperbolic plot. Okay. From this plot, it is difficult to determine Vmax and Km directly. So what they did, they drew a graph versus reciprocal of your reaction velocity versus reciprocal of your substrate concentration, and this plot is called as Lineweaver-Burk plot. From this plot you can easily determine Km and Vmax directly. Okay, and this is nothing but your Lineweaver's Burk equation. This is Lineweaver-Burk equation, or we can say it is nothing but reciprocal of your Michael Menten's equation, which is 1 by V0 equal to Km divided by Vmax into substrate concentration plus 1 by Vmax. Okay, this is nothing but your Lineweaver's Burk equation, or it is nothing but your reciprocal of your Michael Menten's equation. Now, which this can be, this is in the form of y is equal to mx plus 3. So from here you can slope is equal to Km by Vmax. Intercept on the y-axis is 1 by Vmax. Intercept on the x-axis is minus Km. So from this plot, you can easily determine Vmax and Km. Okay. So what is the importance of Lineweaver-Burk plot? From Lineweaver-Burk plot, we can easily determine Km and Vmax. Okay. Thank you very much for patiently listening to the complete presentation.